back, everyone. Welcome to our final discussion on centroids. I just wanted to bring you back to go over one last thing that hopefully will save you some time and give you one more option when solving centroids. So to start, I want to look at our last problem we just solved in part 3, and that's using the centroid of a complex shape, or calculating the centroid of a complex shape. And what we did in that one is we used our equations here, and we did what I would call an additive method. So we split this up into 1, 2, 3 different shapes that were all solid shapes and added them together, basically, is what we did. So that would be what I would call the additive method because we used 3 solid shapes. If I flip this to my next page here and we look at the exact same problem, we can use what I would call a subtractive method, and sometimes this will save you some time, and sometimes you have to use this depending on what your shape looks like. So if I look at this exact shape again, instead of splitting this into 3 solid shapes, I'm going to split it into an overall big shape and then think of the top right triangle as a negative space. So if I look at this, it's like I have a huge solid square that if I outline that with blue maybe, it's not going to be a perfect outline. But I look at this, my blue could be considered area 1, which would be a positive area, and my triangle here inside the green would be area 2, which would be considered a negative area. So now my calculations get a little bit simpler. I just have to remember to use negative areas. So I have 1 and I have 2. And forgive me for just using green for the sake of running through this a little bit more quickly. So I've got my calculations up there for a complex shape, for a rectangle, and for a triangle. So we can just dive right in. So if I look at this overall area as shape number 1, my rectangle, the centroid of shape 1, my square, I guess, not rectangle, is base over 2. So I have 6 over 2. My centroid equals 3 inches. My y centroid, the height is 6 inches. So again, rectangle h over 2. So I have 6 over 2, also 3 inches. And the area of this, I'm considering that to be my starting shape. I started with a solid square. So my solid square is an area of 6 times 6, so I have 36 inches squared. Alright, so there's shape 1. Pretty straightforward, pretty easy. Remember, I just think of that as if I started with a solid square and I took away that triangle. So now, if I go to shape 2, my triangle, I go through the same process. So because it's a triangle, I have my centroid. Now, the thing we have to keep in mind here is my centroid location, again, is from my absolute point. And if we remember our rule for right triangles, our centroid is always located a distance away from my right angle. So the key here is remembering that I'm actually starting, I use this as my reference point, so I'm starting at 6 now because I'm going over 6. So I'm going to say, like last time where I started at 3 and then I added more on because I was starting over in here. Now I'm at 6 and I'm working my way backwards. So I'm going to say that I'm at 6 minus my base of this triangle is 3. So I have 3 over 3. And so my X bar location is at 5 inches. My Y bar location, again, I'm starting up here at 6 and I'm working my way down for the height of this triangle because this triangle is what you could maybe consider upside down. So the centroid is going to be going to the left and down. So I'm going to start once again, let's separate these, at 6 minus, and because it's still 3, I do 3 over 3 again, and the location is again at 5 inches. So to recap, just one more time, you always are starting from the right angle of a triangle, so you have to, and you always have to use the reference point. So if this is my 0 point, I've started way up here at 6, and I'm working my way backwards to the left and down from the top. So I have to do 6 minus my centroid location and 6 minus my centroid location for both my x and my y. Now the last little bit you have to remember is that because we removed this triangle, my area is going to be considered negative. So I'm going to say negative, and we'll say it's a negative 3 times 3 over 2 to give me negative 4.5 inches squared. So that is my 9 divided by 2, 4.5 inches squared, and because I removed that triangle from my overall big square, I'm considering that area to be negative. And the only thing we have to worry about being negative now is the area at the end. So I can do my exact same equations as I did before. X bar of this whole shape is going to be equal to shape 1 times its area, 3 times 36, plus, and now I'll have 5 times negative 4.5. So it'll be subtracting that centroid area away, divided by area plus area. So I have 5 plus negative 4.5, or I could just write minus 4.5 because I subtract, or I add together my areas. So 5, sorry, not 5, I went to this number, 36 minus 4.5. There we go. Okay? So now, based on my last problem, if I check my answer, I believe it was 2.7. So if I look at that, 2.71 is what I should expect, and I should expect that for both. So let's plug that in. So again, I'm going to do 3 times 36 plus 5 times negative 4.5 equals that, divided by 36 minus 4.5. And if you look, you can still see my old numbers up here. I've got that 85.5 showing up again, so that's a good start. I hit equals, boom, there it is. 2.71 inches. So the key here, remember, is that you're using your negative areas, and that's all you're worried about. Is the only thing that's negative is your area. So if we go y bar to finish this off, we'll say that we want 5 times 36 minus 5 times, no, sorry. Getting ahead of myself. 3 times 36. 3 times 36. Because I'm using this y bar and this area. Sorry about that, shape 1. Minus 5 times, plus 5 times negative 4.5. Let's go through that one more time. I'm on shape 1, y bar total, so I have 3 times 36. 3 times 36 plus, because I'm adding these together, plus 5 times negative 4.5. Sorry about that. Okay, divided by, again, we do our areas, and we'll do 36 minus 4.5 because we use the negative area, and we're just adding those together. So if I do this again, I have the exact same numbers that I had before, so I don't even need to type it in again. 2.71 inches. So there we go. 2 different ways to do the same problem using this subtractive method. is going to be necessary for some of your problems. I believe there's a problem in your practice problems that'll be this way. So good to know how to do both the additive and the subtractive method. 2 important points on this one. Your triangle are always starting from your right angle. So if your absolute location is way up here at the right, you need to remember you're working back and down. And then your areas, whatever you are removing from your hole, you need to make sure that that is just a negative area. Your centroid locations are not negative, just your area is negative in that area, in that problem. So, good luck. These videos are always here, so make sure you come back to review them as needed. And that's all for centroids.